Hi everyone, and thanks for watching my online lesson on linear nth term. So if you're studying foundation tier, these are the only types of sequences that you'll need to be able to find the nth term of. If you're studying higher, you'll also need to be able to find the nth term of quadratic and geometric sequences as well. So let's look at this example here. This question says, write down an expression in terms of n for the nth term of the number sequence. So it's basically asking me to write an expression in algebra to represent this sequence here, to show what is happening. So if we look at what is happening, to get from the 3 to the 7 here, they are adding on 4. And to get from the 7 to the 11, that is also plus 4. And you can see, I'm just checking it is definitely plus 4 the whole way along, and it is. To get from one term to the next, we're adding on 4. Now there is another sequence I know that does this, and that's the 4 times tables. If I write down the 4 times tables, they go 4, 8, 12, 16 and 20. So this sequence is very similar to the 4 times tables. Now the 4 times tables are 4 times 1, 4 times 2, 4 times 3. It's basically 4 times some number. So we can represent the 4 times tables in algebra by 4n. 4 times some number. Now this sequence that they've given me isn't quite the 4 times tables. I'm just going to write it underneath this. So theirs is 3, 7, 11, 15, 19. It's very similar, but actually to get from this sequence to this one, it's minus 1. It's 1 below that. So their sequence is the 4 times tables, but take away 1 each time. So that's the nth term that they're looking for. It's 4n minus 1. Let's look at one more example. This one's slightly different. If we look at what's happening here from one term to the next, it's actually going down 4, so it's minus 4 every time. Now this isn't similar to the 4 times tables because the 4 times tables goes up in 4s. It's similar to the minus 4 times tables. So by minus 4 times tables, I mean minus 4, minus 8, minus 12, minus 16. That's the minus 4 times tables. So this is minus 4 times some number. Now this is similar to the sequence they've given me. It's going down 4 every time. Again, I'll just write their sequence underneath so we can see what the difference is between the minus 4 times tables and their sequence. And if we look, to get from the minus 4 times tables to their sequence, it's actually plus 25. So their sequence can be called the minus 4 times tables, but add 25 on every time. So that's the nth term. It's minus 4n plus 25. Here's 2 questions for you to try. Pause the video and then unpause when you're ready to see the solutions. Here's the solutions. So the first one is like the 7 times tables. It's going up in 7s, but it's actually minus 5 away from that. So it's 7n minus 5. And the second one is like the minus 3 times tables, but it's plus 26. So it's minus 3n plus 26. Here's the next skill you can be tested on. So once you have an nth term, you can use that nth term to find any term in the sequence. So that's why we find the nth term. That's the purpose of it, is to find any term in the sequence without having to carry on the sequence. So this first question says the nth term of a sequence is 7n plus 2. Find the 20th term of the sequence. So because they've already given me the nth term, this is a really quick question. All I have to do is substitute the number 20 in for the n. So it's 7n, so that means 7 multiplied by n. Now n in this case is 20 because they're asking me to find the 20th term, and then I'm going to add on 2. So this is 140, add 2, so it's 142. There's a much quicker way of finding the 20th term without having to write out the sequence till I get to the 20th term. So the second question says the nth term of a sequence is n squared minus 5. Find the 6th term of the sequence. So the 6th term is going to be 6 squared, take away 5. So 6 squared is 36. And then take away 5. So that's 31. So that's what the 6th term of that sequence will be. Here's 2 questions for you to try. Pause the video and then unpause when you're ready to see the answers. Here's the solutions. So the first question you should have done 3 times 50, take away 5, which is 145. And the second question was 2 times 4 squared. And you have to be careful here to use BIDMAS. So we do the 4 squared first, which is 16, then multiply that by 2. We don't do 2 times 4 is 8 and then do 8 squared. So the answer is 32. Okay, here's the last skill that we're going to cover in this video. This says, here are the first 5 terms of a number sequence. Explain why 387 is not a term of the sequence. So in this question, just looking at the sequence, it's fairly obvious why 387 isn't going to be in the sequence. And the reason is, if we look at the numbers, we've got 3, 8, 13, 18, 23, then it will be 28. All numbers in this sequence are either ending in a 3 or an 8. And 387 does not end in a 3 or an 8. And it's as simple as that. That's 1 mark and that would be a sufficient explanation. They do give you questions where it might not be as obvious why. Sometimes it is really obvious, like the last one, and we can just give a written explanation. But there is another method that it's useful to know, so that if it's not as obvious, you can use this method. So this question says, here are the first 5 terms of a sequence. The first part of the question is find its nth term. So I'm going to do that really quickly because we should know how to do this. So it's going up in 6s, so it's similar to the 6 times table, but it's 3 away from that, it's down 3, so it's 6n minus 3. So once I've completed the first part, the second part says, Ben says that 150 is in the sequence. Is Ben right? You must explain your answer. So as before, with this sequence, there is a reason why. If we look at what's happening, because it's going up in 6s and it starts with an odd number, all the terms in this sequence must be odd. So that would be a sufficient explanation. But if you're in your exam and you're struggling to spot a reason like that, and sometimes there isn't an obvious reason, there is this other method that we can use. So if 150 is in the sequence, there will be some value of n that 6 times n minus 3 gives me 150. So I can set that up as an equation. So 6n minus 3 equals 150. If I can solve this equation to give me a whole number answer for n, then it is in the sequence. So I'm going to add 3 to both sides. That's 6n equals 153. And then divide by 6. So n is, and 153 divided by 6 is actually 25.5. So this tells me that it is not in the sequence. It would actually be between the 25th term and the 26th term, but it's definitely not in the sequence. And I'd need to make sure I write a little sentence to say that underneath. Here's a question for you to try. So find the nth term of this sequence first, and then is 319 in the sequence? Try and use the method that I've just shown you, because for this one there isn't an obvious reason whether it would or wouldn't be in the sequence. So you need to use the method I've just shown you. Pause the video and then unpause when you're ready to see the solution. Here's a solution. So you should have got that the nth term is 4n minus 1. So I can put 4n minus 1 equals 319. And if I can find a whole number for n that will work for this equation, then it will be in the sequence. So when I solve this equation, I get that n is 80. So this time, yes, it is in the sequence. It's actually the 80th term. You could, in your exam, write out the sequence until you get to 319 or until you go past 319. But it's only a 2-mark question and that would take a long time. You probably even haven't got enough space to write that out. And as silly as it sounds, you're only adding 4 each time, but you're likely to make a mistake going all the way up to the 80th term. So you need to know this method. It's much quicker and easier. Okay, there's just one last question I want to show you in this video, and it's this second part here, this part B. It gives you a sequence in the first part and it asks you to find the nth term of this sequence, and in the second part it says that there's another sequence whose nth term is 8n minus 16. John says that there is a number that is in both sequences. Explain why John is wrong. Now this is probably one of the hardest nth term questions that can come up on the foundation tier, and it doesn't come up very often. But if you want to pause the video now and have a go and then unpause when you're ready to see the solution, then please do. Okay, so here's the solution. Part A was just finding the nth term of a sequence, so that's 4n minus 5. Part B, I started by writing out the sequence 8n minus 16. So substituting in 1 first, that's 8 times 1 minus 16, which is 8. Then substituting 2, 8 times 2 minus 16 is 0. And then 3, 8 times 3 minus 16 is 8. So I got this sequence here. So you can see it's going up in 8s. This is 8n minus 16. Now what I noticed looking at this sequence here and this one at the top here is that this one is only odd numbers. They're adding 4 each time. It's made up of all odd numbers. Whereas this sequence is all even numbers. So there's never going to be a number that's in both sequences. So my explanation is that 4n minus 5 is odd numbers and 8n minus 16 is even numbers. Thank you for watching.